Hey everybody, it's kind of weird seeing the classroom empty like this back up at school. Hopefully you guys are doing good and everything. What we're going to do is we're going to change things up a tad bit, how we do our notes. We're going to give you guys hopefully filled out guided notes. You can kind of read through the descriptions. I'll explain it while I'm doing the problems, but then hopefully we'll just do the problems. That'll make your life a little bit easier, streamline things. And again, make sure you guys reach out to me if something doesn't totally make sense. So what we're going to do is we're going to do 8.5 solving log equations, but I'm only going to do the first 4 examples today. So we'll kind of knock these out, see if you guys can kind of follow along. But as we go along, I'll kind of reiterate the steps and all the information above. So you guys, number 1 has log base m of 25 is equal to 2. So again, you guys make sure you read it as log. You say the word base, you read the base, so log base m of 25, and that equals 2. So the notes say that in order to solve a log equation, if you got a log on one side, not the other, move the base convert. So I kind of just do it in a little melody, you know how I do little silly things. So you guys, I'll take the base and I will convert it to an exponent problem. That gets rid of the log. And we're not really that great at logs maybe anyway, so we don't want it to be a log problem. So we have 25 still on the left side, and then the log goes away when we move the base, and the base becomes the base of an exponent problem, which is m squared. And now we solve like normal. I take the square root of both sides, don't forget your plus or minus. And to get m by itself, then I'll go ahead and get plus or minus 5 is equal to m, but we have an issue. We have to make sure that we follow the restriction. So when you look back up, you're like, oh, the base has to be a positive number and it's not allowed to be 1. The argument has to be a positive number. So whenever I take this positive 5 and plug it into the base, everything is good. But when I take negative 5 and plug it in there, I'm not allowed to have that base. So in your notes, you'll see that I say negative 5 is not a valid solution, and we only get to keep positive 5. All right, next, number 2. If I have log base x plus 5 equals, of 8 equals 3, again, I do my little melody. When you got a log on one side, not the other, move the base convert. So I take the base, I move it to the other side, and now it's an exponent problem. I have 8 is equal to the exponent problem of quantity x plus 5 cubed. Now in order to get this x by itself, I have to cube root both sides. You do not need plus or minus when you do an odd index radical. And please remember the type of root it is the index, so 3 is an odd number. The cube root of 8 is 2 equals x plus 5. When you minus 5 on both sides, you get negative 3 is equal to x. Now I already boxed it. I shouldn't do that. You can't really box your answer until you check. Now I did get a little bit lucky, and you know it's valid if you read the notes. Because negative 3, if you plug it in there, negative 3 plus 5 makes a base of 2. That does make a positive base. You're allowed to have negative answers as long as when you plug them back in, your restrictions are met. So make sure you definitely look at that. All right, you guys, we only have 2 more examples for today. Try to keep things short and sweet for you. Number 3, when we have log base 64 of 2x equals 1/2. Again, do my little melody. If you got a log on one side, not the other, move the base convert. So I could take the base and I'll convert to an exponent problem. I have 2x is equal to 64 to a power of 1/2. But if you read the guided notes, what does a power of 1/2 mean? Well, it's actually a square root. So this is really the square root of 64, which is 8. So now I have 2x is equal to 8. Divide both sides by 2 and get a solution of 4. Now notice I didn't box it. I do have to check. 2 times 4 is 8. The argument has to be a positive number. 8 is a positive number, so it's a valid solution. Now our last example of the day, number 4, when we have log base 2 of x squared plus 6x equals 4. Again, when you got a log on one side, not the other, move the base convert. So when I move the base and convert, now it's an exponent problem, no longer a log problem. And I have x squared plus 6x is equal to 2 to the power of 4. Well, 2 to the power of 4 is not 8. 2 times 2 times 2 times 2 is 16. So now I have x squared plus 6x is equal to 16. But if you ever have x squared and x in a problem, we like to solve by factoring, but we need one side to be 0. So move everything to the left side. I'll do that by minusing 16 on both sides, and I'll solve by factoring. Now, if you guys aren't exactly sure how to factor this, you could look up on YouTube some extra videos, but it's MA method, okay, or AC method, some people call it, but hopefully we're decent at factoring at this point. And it is quantity x minus 2 times quantity x plus 8 is equal to 0. Now when I solve them each separately, in my notes, you'll see that I take x minus 2 equal to 0, x plus 8 equal to 0. When we solve these, this would give me a solution of positive 2. This would give me a solution of negative 8. Now I'm allowed to get negative answers as long as I plug them in and they're okay. But let's check 2 as well. 2. 2 squared is 4, plus 6 times 2 is 12. 4 plus 12 is 16. That is an okay argument. Now you might think the negative 8 is not okay, but it is. Because if you take negative 8 squared, you get 64. I'm going to bank that in my head. When you take negative 8 and plug it in there, 6 times negative 8 is negative 48. So 64 plus negative 48 is a positive number. And you don't really need the value. It's just the fact that it's positive is okay. So it's a valid solution. Hopefully this helped you guys solve log equations with log on one side. Now whenever we finish our notes tomorrow for 8.5, we'll see, well, what happens if we have logs on both sides of the equations? All right, it's your boy, Mr. P.